I think TypeScript is moving into a different era, and the big reason is AI. For a long time, we have all picked tools based on what felt familiar, or based on what had the most examples, or the most answers in Stack Overflow, or based on, most recently, what AI was most likely to know. And I don't think that argument really holds anymore. Nowadays, there is not much excuse to say, I will not use this because AI doesn't know it, or I do not know it yet. AI can read the source code, it can read tests, it can find examples, it can trace types, it can verify behavior. All of this way faster than any human could. So the question is changing. The question is not what do I already know, and it is not what tool is the most common. The better question now is what gives me the strongest model, what gives me the better guarantees, and what makes the code easier for both me and the AI to work on. And that is why I think the next era of TypeScript is going to look very different on both the front end and the back end. On the front end, I think we're all going to look for coherence. Front end is notorious for being a total mess when it comes to libraries. We have a library for async state, then a library for sync state, then a library for error handling, then one for telemetry, one for web workers, and so on. We all want better boundaries, better state models, and I guess clearer ways to represent loading, failure, async work, etc. And on the backend, well, the shift is even more obvious. We all want better errors, concurrency, dependencies, queues, workflows, observability, everything that ultimately entails a production API. And that is why I think Effect will be the future of TypeScript. And the reason for that is it ships a huge ecosystem of different libraries. So you have the front-end libraries, you have the back-end libraries, it handles errors, concurrency, observability, all natively, which you can use in any environment. It ships its own schema validator, which is bidirectional, so you get decoding and encoding under one definition, which is way more powerful than other alternatives. It also has abstractions for WebSocket, for web workers, and so on. And the testability is great because it makes dependencies first class. So each computation, so you can see what each computation requires, and then for your tests you can create mock implementations or do whatever you want. Anywho, if we scroll down, we can see this code example right here where we have without effect and then with effect. So without effect, if we want error handling and treat errors as values, then we need to handle this imperatively ourselves. I try catch and then have a discriminator, which would be this OK boolean, and then do the rest. With effect, all you need to do is use your HTTP client, do a get request, and that's it. And this is going to handle the errors for you. So the request errors and the response errors. What if you want retriability? Well, in this case, you'd need to create this execute function that is going to take in the attempt, so it can apply the cap, which would be the max retries, and then this get to do would take in the retries, default to 3, then a base delay, and then you need to handle the rest yourself. So everything is completely imperative. You need to make sure that you're capping things right, that you're handling the different branches, and so on. With effect, all you need to do is say effect.retry, and then you can pass in a schedule. And here you can compose your schedules however you want. So you could say, I want this to be exponential and then max times 3. Or you could represent unions here, intersections, have this schedule take in the errors so it can introspect it, maybe for retry after headers, and so on. And everything is totally declarative. Now, what if you want interruption? So abort controllers. Well, in the case where you do not use effect, you need to pass in the signal and then you need to wire everything yourself. With effect, all you need to do is say effect.timeout, or you could even remove this timeout and this by itself would be interruptible. In effect, everything runs in something known as a fiber, which is just a handle that you can wait for, a handle that you can interrupt, etc. So you get total control over that behavior. And finally, observability, which is arguably the most important one out of these four, because with observability, you can understand timings, you can understand what went wrong, where and why, etc. Without effect, well, it is very declarative. You have to say start the active span. You need to make sure to end the span, set the data, the events, and so on. With effect, all you need to do is say effect with span, and that's it. Now, before moving on, if you want to learn everything about effect, make sure to check out my course Practical Effect. And in this course, I'll teach you the most important thing, and that is the pragmatic theory that you need for effect. You may be able to write effect code, but if you do not understand the different APIs, the conventions, the design decisions, then you will not write good effect code, and the AI will not help you much. Now, this is based on V3, which is the stable version. They are working on V4, however it is still in beta. But once they officially release V4, I'll be updating this course to V4. And you will have access to both V3 and V4, just in case you end up working on a V3 in quotation legacy project. Link is in the description. So what does Effect actually offer? Well, let's take a look at the core package. So here in their GitHub, if I come over to packages and then Effect and then source, you'll notice that it comes with a lot of modules. So it has Effect, which is the core. It models success, errors, and requirements. You also have a datetime module, so no need for loxon or date FNS. It comes with data for constructing objects that implement hashing and equality so that you can compare by value recursively instead of referential equality. You have a cron module. You have the context module, which is for dependency injection. You also have the duration module so that you can work with durations regardless of their unit of time. So you can add milliseconds with seconds because it abstracts all of that for you. Then you also have execution plan, which is particularly useful for the AI world where you want fallbacks. So what if X provider fails? Then let's fall back to this other one with your own schedules and conditions. But you can obviously generalize this and apply it in any context where you need an execution plan with fallbacks. It also comes with clock, so you get deterministic manipulation of time, so you can advance the clock, you can provide a real clock implementation, etc. All in all, helping you write deterministic tests. It also has config for environment variables, where you can have different sources and different fallbacks, so you can read from an env file or fallback to a cloud provider. It also has brand for nominal types, particularly useful for entity IDs, so you do not mix them up. You have an array module, which helps you replace libraries like remeta. So you have array.groupby, you also have ordering, etc. And if I scroll down, as we can see, we have the fiber module. We also have hashmap, hashset, iterable. We also have list, which I believe is for linked lists. We also have mailbox, which is for queues, but you can also model errors. So you can fail this mailbox or this queue, and all subscribers will get that error. We also have match, which is a replacement for TS pattern. We have metric, which is for OpenTelemetry. we have option. So if you have used Rust, this is great for declarative modeling of the absence of a value. So you can operate on the presence of the value without worrying about its absence. Then you also have the order module, which is for sorting. You have a pool module, so you can manage a pool of resources. Could be database connections, for instance. It also comes with a rate limiter module, and you can provide an implementation you want. Could be an in-memory rate limiter or a Redis-backed rate limiter. Then it has RC map, which is reference counting map, similar in spirit to Rust, but it leverages another concept called scope, which is for resource management. You also have a redacted module, so you do not accidentally leak private information in your logs, and a lot more modules. As we can see, we have schema, we have a schedule, we have streams, of course, which are pool-based, and many more modules. Now, in this case, well, you could simply point the AI to this source directory, and then it can look for the best fitting modules that you need for your code. And that way you learn with the AI. So the AI can determine that the best module that you need to use is FiberSet or a fiber map. Well, now you know, and you can look at the code it writes. And since all of this is backed with tests, as we can see here, then the AI has lots of reference material, which is incredibly important in the world of agentic coding. Now, this is the core package, but what other packages does it offer? Well, it offers cluster for distributed systems. It has platform, so file system, HTTP clients, etc. It comes with RPC, so a replacement to tRPC. But the power of RPC is that you can use it for pretty much anything. You can use it for web workers, you can use it for HTTP APIs, or with a one-liner, you can use WebSockets. You also have the SQL packages, you have the vtest package, and I forgot to mention, but in the platform package, you have the HTTP API. So if you need to serve a RESTful API, you can use all of these modules right here, including Swagger, as we can see here. Now, all of this is useful for both the frontend and backend, but a lot of these modules are meant for the backend, of course, like these platform ones, HTTP API, file system, cluster, of course, CLI, the AI package, all of these are meant for an API. But what about the front end? Well, for the front end, you already have a lot. You have RPC, which you can use for web workers. You have the HTTP client for requests, and you have the core package. Everything there can be used in the front end. Telemetry, concurrency, error handling, interruption, etc. But if you want to, for example, replace Stansta query and Sustand, there's this library called Effect.ts, and this one is by TeamSmart, which is actually an official maintainer of Effect. And for V4, Effect.ts will be in the core packages that they offer, not as this standalone repository. And this one right here is heavily inspired by Jotai. So if you have used Jotai, this library right here, Effect.ts will be second nature to you. So the core idea is you create atoms, and that's it. So you can say atom, make, and then the eager value. But since it uses effect, then you can create an atom with an effect. And since effects model requirements, the succeeding value, and the possible errors, then it will intelligently use this overload right here. So it is an atom that resolves to a result. And this result is very similar to never throw, where you have the success branch and the failure branch, but it is augmented so that you have the waiting state. So you can, in a component, subscribe to the failure, the success, and the loading states, just like Tanstack query. And you can also work with functions. So you can say atom.function, then an effect here, and then you can do your API calls. You can call a web worker here. You can do whatever you want. And to consume it, you say use atom set, and then you pass in the atom, and then you get the function here. And if you want the value of this log atom, so you can show a spinner while it does the work, the mutation, then you can say use atom value. So if it is synchronous, then you're going to get the value right away. But if it is async, so in other words, it's an effect, then it is going to give you back a result. And as we can see, we can say result, get or else. And there's also, if we come here under packages and then atom, which is the core, and then source, and then result, and then take a look at the symbols, as we can see, we get the success branch, so the value, and the discriminator is this underscore tag. Then we get the failure branch. We can check if it has been interrupted, and again, since effect handles interruptibility by default, you do not need to do anything other than writing out your effects. You also have the waiting property. You have a get or throw. So if you have a parent component that is guarding all children, then you can say result dot get or throw and unwrap it directly. And you also have this builder, so you can say result.builder, you pass in the result, and then you can attach all of these. You can say on waiting, let's render this, on defect, render this. We have or else or null, we have on initial or waiting, on success, and then on specific error tags, etc. So it is combining both Jotai with Tanstack query, but again, it is way more composable, and the AI will actually do a wonderful job at working with all of these libraries, partly because it is very well thought out, but also because there are tons of tests. So as we can see, the atom test file is gigantic, so the AI has tons of reference material to work with. Now this is for the state management. What about forms? Well, again, we have this effect form library, and this is actually a library I made powered by Effect.ts and Effect. And this one's different than Tanstack form or React hook form in that all of the forms are driven by schemas. The schemas are first class. There is no notion of adding a validator. You need to provide a schema to create the form. And again, for the state management, I use Effect.ts. So you can subscribe to each field individually. And within each field, you may only subscribe to the value, or if it has been touched, or to the error of the property. That way, you get fine-grained reactivity, which gives you much better performance for free, because everything is powered by Effect.ts. So make sure to check out this library too. And we also have LiveStore. And LiveStore is a library for local first applications. And this one is powered by Effect Schema, and by Effect.ts. So if we come here to Effect.ts, once again, under packages, we have the Atom LiveStore adapter. So with everything that Effect offers in its core package, plus Effect.ts, plus LiveStore, plus Effect Form, you pretty much have everything you need for a web application. Now, if you come here to my channel and go over to playlists, you'll find Effect Cluster, where for now I just have an introduction to the actor model, and that's because I'm waiting for the v4 package to be stable so that I can push out the practical content. Then we have this effect in 5-ish, so as the name suggests, videos around 5 minutes showcasing a specific module. Then we have build an app with Effect, so you can take a look at how to define an API, how to create your own services, etc. And then we have the main Effect playlist, where I teach duration, I teach option, etc. So if you take a look at my videos, I have a video dedicated to effect form. I have a video on how to wire effect with TanStack start, then how to wire effect with upload thing, everything in the front end. This one is very, very comprehensive, and you can really get a feel for the power of effect. The code there isn't simple at all, but without effect, it would be 10 times bigger. Then how to work with WebSockets, then an Effect Atom crash course, a general introduction to Effect, and well, as you can see, I have a lot of videos on everything about Effect, including the HTTP API library. So make sure to watch every single video of mine. Now let's take a look at the most important and interesting bit, and that is how to use AI to write effect code. Well, the most important thing is cloning the effect repository and any effect libraries that you will be using. So if you're going to use effect, RPC, HTTP API, make sure to clone the effect repository. If you're going to work with Effect Atom, clone Effect Atom. Then you need good global instructions. So in my case, I like to have a rules MD, and I'll show you how that might look like for Effect projects. And I have this external libraries section where I tell the AI to distrust its built-in knowledge for external libraries, frameworks, and tools, where before using a third-party API, it shall check the source code in this directory. And if the cloned library does not exist, then it needs to shallow clone it. And then I tell it to prefer library source and tests over documentation. Use docs only when source and tests are not enough. And I cannot stress this enough. This is the most important rule. AIs are great at understanding code. They are great at navigating code bases. Documentation is for humans, not for AIs. And AIs, just as humans, will do a much better job at looking at the actual source code. The only difference between the AI and the human is that we would take way longer understanding the conventions, where is what, how are the modules defined, where are the directories. Well, the AI can do all of that a million times faster than a human. So that's why AIs should prioritize the source code and tests. And if it cannot get the source under open source for whatever reason, then it should use node modules as the fallback. But this should be the last resort. Now, as for the project, I have an agents MD, a rules MD, and a knowledge directory. So in agents MD, I tell it must read rules MD before doing anything else. And I'll show you how that looks like in a moment. And then we have the skill files. So in my case, I have all of these v4 skill files for RPC, SQL, fast checking, Atom testing. All of them are mostly for showing patterns to the AI, not as the source of truth of how to work with the library. So I found that if you have a skill on how how to use a module, but it is pretty much what it could find by itself looking at the source code, then it is completely useless. Just let the AI look at the source code. But if you have a skill that shows patterns, tells it what to do and what not to do, then that is a good skill to keep. And that is the case for every single one here. All of them have tons of patterns and real world examples. And as we can see, we have this repository uses Effect v4. Then I tell it how to clone v4. And as we can see, I tell it to distrust its built-in knowledge of Effect. I also tell it to use bun to validate the behavior of the library and, well, any code in general, and other general instructions. Now, if we take a look at rules, this is all about Effect. So how and when to use Effect function and function untraced, how to convert typed errors into defects. So I tell it to never use Effect or die, handle typed errors explicitly with Effect catch tag, catch tags, etc. Do not use the global error class in app code. Now I have a lint rule for this, but it still made this mistake a lot. So I prefer to also add it here in the rules file, just to prevent the AI from doing it at all. Then other rules like do not probe errors with checks like if tag is in error, and a lot more rules. And as we can see, it is quite extensive. I have one dedicated to Effect, another one for architecture, another one for front-end state, etc. One of the most important rules in Effect for letting the AI quickly identify and diagnose bugs with layers, in that it forgot to provide X service to Y layer, etc. It's this one. Final live layers must be typed as layer of provided services explicitly. That way, if it forgot to provide a layer, TypeScript will complain right away, instead of complaining at the final composed layer, which is usually in your main.ts file. And then for knowledge, well, as I told you, I have a rules directory and a skills directory. And here, for example, on Effect atom v4, I tell it how to create atoms, how to use async result builder with some concrete examples, how to use atom family, how it works under the hood, how to use the runtime, and so on and so forth. If your project has all of this, AI will do a wonderful job at writing Effect code. The most important thing out of all of this is telling the AI to check the source code of the library. Anyway, that's it for this video. Give Effect a try with AI. AI will do everything for you. Point the AI to the cloned repository and tell it to build a game or an API or a frontend, whatever you want. And you will see that the AI will do a much better job writing Effect code as opposed to writing vanilla imperative code where it needs to create tons of utilities from scratch. I hope you enjoyed the video, and if you want to see more content like this, make sure to subscribe. I'll see you in the next one. See ya.